Welcome back to the EOT for grade 12 advanced. In this video we are going to go over questions 13 and 26, one from the multiple choice question 13 and one for the free response, a question 26. So let's start with the MCQ question 13. Apply the chain rule for differentiation. As if you remember, Yashab, we already explained the questions. However, we have like two questions. Some people still get confused, so I will explain them here very quickly because it's a very easy thing. Now, it's about the fact of the even and odd functions. Let me ask you first, what is the even function and what is the odd function? Actually, we need to link both of these to the degree of the function, which means the even function, that it's the function that has a degree of an even number, while the odd function that has a degree of an odd number. So very obvious, very easy. The even function that has a degree of an even number, the odd that has the degree of an odd number. All right, now let me remove this from now. All right, so let me just give you two examples, like f of x equals, let's say here we have 2x to the power of 4 minus 5x to the power of 3 plus 2x minus 8, and here we will write negative 3x to the power of 5 plus 3x to the power of 3 minus 2x squared plus 1. Just two examples very quickly. So the first thing I should find here is the degree for both of them, and here the degree as well. Now, sorry, the degree. Now, can you tell me what is the degree here? So when we have a question like this, we look at the maximum power, which is 4. So it's a degree of 4, and beside it we write as 4 is an even number, so this is an even function. And on the other hand, what is the maximum degree here? Maximum power is 5, so it's of the 5th degree, or a degree of 5, which is an odd number, so that it will lead us to an odd function. All right. Now I will not complete fully the question, but I will just give you one example here. If I'm trying to find f prime of x, remember, Shab, what will happen here? We will multiply, so it will be 2 times 4 is 8, x to the power of 3. Let us continue this one. 3 multiplied 5 is 15, x squared plus 2, and here f prime of x will be 5 multiplied 3 is negative 15, x to the power of 4 plus 3 multiplied 3 is 9, x squared minus 2 times 2 is 4, and we have here x. Right. To be honest, let's see what will happen after differentiation to the degree for both questions here. What happened? Now, what is the degree in this question? It's a 3, which means it's odd function. And now for this one, the degree is 4, it's an even function. Now, from all of this, to be honest, it's very obvious. When we usually differentiate a function, all the exponents of x will be multiplied by the coefficients and we subtract 1. So every time, what will happen from a function to its derivative, the degree will be reduced by 1. And same here, the degree will be reduced by 1. So what we can tell now is that when we differentiate any function, we will change it from even to odd, and if it's odd, we will change it from odd to even. So this is how it works. Remember, why is that? Because every time we will reduce by 1. So if it's an even number, when we reduce by 1, it becomes an odd. It's like a sequence. So odd, even, and so on. So every time we subtract 1 from the exponent, so whatever it's a maximum exponent or another one, for the maximum one, it will be from 5 it will be 4, from 4 it will be 3, so from even to odd or from odd to even. So what I can say here, look at the choices that you have. The derivative of an even function is an even function, which means this will be wrong. The derivative of an even function is odd, and the derivative of an odd function is even, which means this will be correct. the derivative of an even, I don't have to complete, but just to see what happens. Even is odd and odd is odd, which is wrong because odd is not going to be odd, so this one is still wrong. The derivative of an even function is even. Actually, this is wrong. So as you can see, the derivative of even will be odd, the derivative of odd will be even, so this is the only correct choice here, right? Now, another question about the odd and even functions, but using the graph. First of all, just I will give you like two examples here for everyone, and we need to discuss something else. Let's say I have an even function. It could be drawn like, let's say, a parabolic shape, for example, like this. All right? Just imagine that I'm drawing it accurately. So if it's a parabolic shape, we know that the parabolic shape is symmetric. And when it's symmetric, it's symmetric about a line. Like here we have the line. We call it the axis of symmetry. So this is the axis of symmetry, right? Because every point here has a reflection on this line to the other side. If I have a point here, it will have a reflection. Even the one on the line, it will be the same. So that's why it's the even functions are like reflected on a line. That this, in case if this graph is a, as we said, is a symmetric graph, it doesn't have to be all even graphs. Symmetric graphs. But for example, if it's x power 4, it could be drawn something like this. Is it a symmetric graph? If you can try to split it from here, actually there is no image on the other side, which means this is not a symmetric graph. So we have a special case in this question. He's talking about symmetric graphs only. So if it's a symmetric graph, as explained, it will be like any symmetric even graph. We will have an axis of symmetry. What if we are talking about an odd graph like this one? Let me draw it like this. Just I will try. No. In a second. So we move this back. Now imagine that I'm drawing a question like this. If it's an odd graph, it will be symmetric as well. Imagine this is a symmetric graph, but it will not, if I will say it's a symmetric on a line, is this correct? Look, if this point will reflect over the line, on the other side we have nothing. Same as here, if it will go to the other side, nothing, which means we can say for the odd graph it's symmetric about the line. But we have another case of symmetry, if you remember, symmetric about a point. Symmetric about a point, which usually will be the point at the center of the graph. How is that? Just I will try to make it as accurate as possible, like this. Actually, Shabab, the point in the middle of the graph in this case will be this point. So the graph now will be symmetric about this point, and we will call it the point of symmetry, not an axis of symmetry. So this one we call it, if you remember, axis of symmetry. This is a point of symmetry. How is that? Imagine that I have any point like this one. So when we have a point like here, if I want to find the reflection of the axis of symmetry, we go like this to the line, go with the same distance, we will find the other point on the other side of the line. But if I have a point of symmetry, we will go to the point, then we will go the same distance, we will find this is the reflection of this point here. Let's try it with another point. If we will go like here, what will happen? We will see another point on the other side. Even if I will go from this part here, we will find another point in a similar location, but on the other side of the graph. This is the symmetry about the point. So as I can say this one last time, in the even graphs, we have axis of symmetry, while in the odd graphs, we will have a point of symmetry. All right? Now let's add something else, because this is a normal one, but we have here a more special case in this question here. So let's say why I'm explaining this. Now, if the graph of a is differentiable for the function f is symmetric about the line x equals a, right? So the differentiable function is symmetric about the line x equals a. What you can say about the symmetry of the graph of its derivative f prime? First of all, this one is symmetric about a point or a line. This is the most important thing. So he says here a line. So we have here symmetry. Or a line of symmetry, right? So which means this is an even graph. This is an even graph. This is what you need to understand from here. If it's a symmetric about a line, it will be even function. So I will choose the point A at x equals a, like let's say here. I will draw a symmetric graph here. Okay, now I will draw this axis of symmetry at x equals a, as we said. So this is an axis of symmetry, and I know now it's an even function. Type. Now, if it's an even function and I want to draw its derivative, the derivative, if it's an even function, let's say, for example, if it's x power of 2, what will be the derivative for this one? It will be like, let's say, if this is f of x equals x power of 2, f prime of x will be 2x. Remember, Shab, if this is a quadratic, the derivative will be power of 1, which means linear. So it will be linear. If this is quadratic, it will be a linear graph. So in this case, if it's an even, and I will differentiate, it will be odd. If it's a symmetric about a line, it will be symmetric at a point. It will be symmetric about a point. So what will happen if I want to draw the derivative of this one on the other graph here? All right. So what I will do in this case, all right, if you remember, it's like decreasing. So I will come from the down bottom here, or like before we start, if you remember, if I have a point, like let's say a critical point here, or a minimum or maximum, I will place it on the x-axis, and this will be the same point as A on the other graph, right? But here we are, if you remember, this one is decreasing, so I will start from below the x-axis, then increasing after this point, so it will be drawn something like this, passing through, of course, like I'm drawing with my hand, passing through the point A, so it will be something similar to this, symmetric about the point. So again, this is the most important thing. If it's a quadratic, for example, it will be linear. If it's even, it's going to be odd. If it's a line, it will be symmetric about a line. It will be symmetric about a point. So let's say that we have 4 choices. So let's see which one we will choose. The graph of f prime is symmetric about the point, about x equals a. It's still a line. We said if this is f prime, it should be, if this is a line, it means it's like an even function. Now it will be an odd function, and it can't be symmetric about the line if it's an odd function. Again, f prime is symmetric about y equals a. Of course, I will not take a line anyway if either it's x or y. Now the second part here, the graph of the third choice, the graph of f prime is symmetric about the point a and 0. So here is the point a and 0. Remember, Ashab, this is x, so the y is 0, which means the point is on the x-axis. So this will be true. So this will be true. Right. The last one, the graph of f prime has no symmetry. This will be wrong, because if it's a symmetric graph, when it's an even function, if I will draw its derivative, it will be symmetric about the point. All right, guys? I hope it's clear now. Now with the free response question 26, understand the mean value theorem and use it in applications. I will go over the meaning of the mean value theorem and the rules theorem first before we dive into the questions. So I put like a comparison as we have done it in the class. Let's say, Shab, I will choose here a point A, and I will go to the other side here, and I will choose somewhere the point B. Like these are 2 values on the x-axis, of course, and this is the y-axis. Now, I will ask you a question. If this is the value of A, how can I find f of A? How can I find f of A? So we will go all the way up to the curve and then go to the left to find the value on the y-axis that represents f of A. As long as this is y equals f of a, because as you know that f of a, it represents the y. Now I will do the same thing for B. So let's say I will go up until I reach the graph, then I will move all the way to the left. And in rules theorem, what will happen here, we will find the same value, or they will meet at the same point. So this will lead us to that f of a will be equal to f of b, and this is a special case. Right? The normal case is that if I have a point A here, and let's say a point B here, for example, let's see how it works on the mean value theorem. We will go to until the graph, then I will go to this side. Now I will mark this point here as f of A. Again, if this is y and this is x. Then I will do the same for b here. Now, what you will notice is that a and b, or f of a, sorry, and f of b are not meeting at the same point, or does not have the same value. So I will write here f of a equals f of b. In this case, they are not. Okay, right? Now, as I said earlier before, this will be the key of the solution of the question, because the question will ask you to check the hypothesis of rules theorem and the mean value theorem to check which one of them to be used in this question. So all what you want to do, you will have steps by finding f of a and f of b. If they are equal, you will say that rules theorem will be applied. If it's not equal, if a is not equal f of b, it means the mean value theorem will be applied. Alright, now as long as we know that, we have a rule we use to find the, for example, let's say f prime of c, it will be f of b minus f of a over b minus a, and this rule I put it in the middle because I will use it for both. However, I put here c because, as we know, ya shabab, we will have to find this rule by both of them based on, like, we choose the value of c somewhere between a and b. We can place it anywhere, like c and b, where I can draw a let's say where we can draw a line that is parallel to this line here, which means it will be a horizontal line. In this case, if this line is like a horizontal line, so if I will say this is the value of c, so if I will go like this part here, we can now draw a tangent line that is horizontal and parallel to the other line. But in this case, the value of c will be somewhere between these, and now I want to draw a line parallel to the line passing through, these 2 points, so it will be somewhere here, and it doesn't have to be horizontal. In this case, if it's we are talking about the rules theorem, what will happen in this case? As long as a, first of all, is not equal b, same as here, a is not equal b. So, and I have to mention this because I don't want the denominator to be 0 anyway. So f of b minus f of a, this means if they are equal, the difference in the numerator will be 0, and 0 divided by anything is 0. This will lead us that f prime of c will be 0, and this will be the rule for rules theorem that will be used in the question. However, on the other side, f of b will not be equal to f of a, and of course b is not equal to a, so I will use the same rule here with no change. So f of b minus f of a over b minus a. So I will not change the rule for the mean value theorem. However, I can use that f prime of c equals 0, and to be honest, it's very obvious from the graph, because we said, if you remember, this is a horizontal line, so it has a gradient of a slope of 0. All right, now let's see how the question will come, and this should be happening in the writing part, ya shabab. So in this case, what we will do, actually the first thing you should remember that we have to mention, of course I haven't mentioned this at the beginning because we have done this earlier in the question. We have to mention that the function is continuous and differentiable at the beginning before we apply or we do anything. So let's say in the first one here, verify the hypothesis of rule theorem and the mean value theorem, and find its the value of c that satisfies the appropriate conclusion. The first thing, this function is a polynomial function. So if you remember the steps, number 1, what I will write here is f of x is a polynomial function, so that it's continuous on, don't forget, -2 and 2. So it's continuous on its given interval here. All right, and number 2, I will write here f of x is, I don't have to be honest, I don't have to write this again as a polynomial, so it's is differentiable on open interval -2 and 2. يبقى the first thing we start with is to mention that f of x is a polynomial function, so that it's continuous on its domain, or the given domain here, which is -2 and 2. And f of x is differentiable on -2 and 2, and we use the open interval here, don't forget. Step 3, if you remember, we will calculate what f of a and f of b. We will calculate f of a and f of b. So I will write it like that way. f of a equals f of b equals. Now, I will write like this, ya shabab. Usually I used to do this. I will replace now a with its value and b with its value. Don't forget, I go to this part and write a and b. So f of a, I now can replace a by, and I can replace b by 2. And where I will substitute these in the original function f of x here. So when I replace x by -2 in this question, it will be -2 squared plus 1, which means 4 plus 1. So the answer will be 5. When I will apply f of 2 here, what will happen? It will be 2 squared plus 1, which means 4 plus 1. The answer is 5. And directly after this, I will write f of a equals f of b, and then check. Now, are they equal? If they are, so this means I will leave it as it is, like I will not change. If they are not equal, I will just put the slash here to say they are not equal. Right. As long as now we have f of a equals f of b, so what I will do in this case, I will say that then in this case I can say that Rolle's theorem will be applied. I can write like a make it more simple. Rolle's theorem will be applied. Right? I will write it that way. Make it as simple as possible. So the Rolle's theorem will be applied. All right. Now, what the Rolle's theorem says. So as if you remember, f prime of c equals 0. But actually, before I will do this, I will find the derivative of the function first. So I will go to the derivative of the function f of x. It will be f prime of x. Now differentiate the function here. X power of 2, it will be 2x plus 1. It's not going to be written. So this is the derivative of the function. Now I want to find f prime of c, which means replacing x by c in the function, it will be 2c. Now I can use the hypothesis of Rolle's theorem, and I can say since f prime of c equals 0, then 2c equals 0. So as long as f prime of c equals 2c, and I know that f prime of c equals 0, so I will equate them. You bet 2c equals 0, divide by 2, divide by 2, so c equals 0. Now, what is the final thing to write here is to write your conclusion. So what you can say here is there is a tangent to the function at x equals 0. So there will be a tangent to the function at x equals 0, and that's it. All right. Now, another example, so we can apply the mean value theorem. I'm telling you in advance, but let's see how it works. You directly share steps 1 and 2. I will not be writing. It's the same thing. Like 1, it's a polynomial. So in the interval, the closed interval, it's differentiable on the open interval. And now I will start directly by step 3. So what I will do, I will find f of a, and I will write f of b. Now, I have to see the interval. It's 0 and 1, which is a and b here. So f of a equals f of, and I'm preparing them. Like I can replace a now by a 0, and I can replace b by 1, and substitute and say, go to the original function here, replace x by 0, so it will be 0 power of 3 plus 0 power of 2. Actually, I don't have to, but you can just showing all the full steps here. It will be 0, then substitute by 1, 1 power of 3 plus 1 power of 2, which means 1 plus 1, the answer is 2. Then I will write f of a equals f of b, and check, are they the same? No, so they are not equal. In this case, which theorem I will use? Rolle's theorem or the mean value theorem? Of course, if they are not equal, now I can say then the mean value theorem will be applied. Alright, so I will use, it means I will use the mean value theorem for this question based on this condition. Now, let's say the mean value theorem, if you remember, says like f prime of c equals f of b minus f of a over b minus a. This is the rule that I will be using. That in this case, I want to find f prime of c. So I will go to the original function now, and what we will do, we will write here f prime of x first, replace t as the last step in this part. So it will be, differentiate this one, it will be 3x to the power of 2 plus 2x, right? Now, I will find f prime of c. This means I will replace a x by c, so it's a 3c squared plus 2c. Now, I can use this rule at this moment. So what I will do, f prime of c will be replaced by 3c squared plus 2c equal, I have f of b and f of a, so f of b is a 2 minus f of a is a 0 over b minus a, b is 1 minus 0 minus a, which is 0, so the answer will be 2 over 1, which is 2. Now, so 3c squared plus 2c equals 2. Now, as long as this is a quadratic equation, so I will bring 2 here and solve. So it will be 3c squared plus 2c minus 2. Don't forget, when we move to the other side, we change the sign. Minus 2 equals 0. Then I want you to hold your calculators and solve. So you will find the answers as a c equals -1 minus root 7 over 3, and you will find the other solution as a -1 plus root 7 over 3. Am I right? You can check and let me know if there is any problem with the solutions here. Now, actually, there is a last step I haven't mentioned before, that when you will find the answers, you have to check if the solution is there within the interval. Remember, Shabab, from the first time we said C must be located between A and B as the given interval. C must be between A and B. Alright, so and actually I forgot to do this here, sorry Shabab for this. C equals 0, you have to ask yourself, is this C, this value of C belongs to the interval? So the answer is yes, so we have to write this down. So we have to say C equals 0 and we say belongs to the interval -2 and 2. This symbol means belongs to, so if you remember, 0 belongs to the interval, so this answer will be accepted. For this one we have two solutions. So if you will change it to, if you try to compare it like this between 0 and 1, I cannot tell. So the best way to do this is to convert them to decimal on your calculator. For the first one here we have a -1.215, for example. And on the other side here, you don't have to write this down, but you may write it if you think you will get confused. This one is 0.54, like approximately 9 or anything, right? So let's now move back. Can you check -1 point something? Does it belong to the interval here? The answer is no. So what we will do, we say it does not belong to the interval 0 and 1, and I will write under it, this solution is rejected. You have to show this, you will take a mark for showing this. The other one, 0.5 something, it means between 0 and 1, of course this is a correct solution, this one is not. So if this is a correct solution, we can say, or we should be writing beside it to show that it is a correct solution. We can say this belongs to the interval 0 and 1, so this is an accepted solution. And the final statement will be, there will be a tangent to the function, or let's say not to the function, to the curve. Yes, there will be a tangent to the curve of the function of f of x, of the function f of x at x equals -1 plus root 7 over 3, plus root 7 over 3. I hope things are easier now, ya shabab, and I'm still here. If you have any questions, just send them to me and I will explain it and send it back to you. Thank you so much and all the best of luck in tomorrow's exam.